Hello, this is the third and final video of this week about modern physics. For this one, I'd like to just take a brief look at some of the wilder sides of Einstein's theories, and that would be his relativity. Uh, he actually has two relativity theories, and they both apply to how space and time are not quite as we perceive it. So, just taking a look at the first idea here. Einstein's general theory of relativity, really, this is the thing he's most famous for, I think, other than his E equals mc squared equation, I assume, um, is that when you're trying to measure the speed of a photon, remember, a photon is like a particle of light, it's always measured at the same speed, no matter what. That is called the speed of light. It's approximately 300 million meters per second. But this doesn't change relative to your own speed. And that's very different. You can consider if you're in a car and you're driving 40 miles an hour, well, that's a relative speed already. You're driving 40 miles an hour relative to what? Relative to, I guess, the road below your tires. So somebody standing on the side of the road measures your car going by, you're going 40 miles an hour. But to a passenger in your car driving with you, you're not moving at all because they're moving right with you. Relative to each other, you are not moving, in fact. So speed is a relative measurement. Light doesn't obey that rule. Whether you're flying right next to that light beam, like the two people in the car, or you're the person on the side of the road watching that beam of light go by, both people would measure that light being the same speed. And so that kind of seems like it breaks physics. How can that be true? How can there be no relativity between the observed speeds uh, if I'm moving and you are moving? Well, it's because time and space actually change while the speed of light does not. So I have in here time and space are fluid. They are not fixed into certain properties. So specifically, time and space are changed due to Einstein's relativity theories uh, by time dilation and length contraction. Uh, you may have heard the word dilation before with eye exams. Um, a lot of you might remember if you go to the eye doctor, they will put those drops in your eye, and that makes your pupil open up or dilate. Time dilation is time stretching, and length contraction is like it sounds. Length shrinks down. Um, there's a lot of nuance to why this happens, but to keep it simple, the faster something moves through space, the slower it moves through time. This is true of all things. Um, these relativistic effects are very difficult to observe unless you are going very, very fast. And so in our everyday life, we really don't ever notice these things. Um, if you have seen some of these movies, a lot of science fiction movies use Einstein's relativity in part of their overall plot. The best example I can think of is the movie Interstellar with Matthew McConaughey, where he travels in a spaceship through a wormhole and he goes kind of around a black hole super fast, and time for him is very different for time for everybody else back on the Earth. The original Planet of the Apes movie takes advantage of a little bit of a wormhole relativity, where the main character begins the movie in a future Earth where uh, chimpanzees have evolved to become more like humans. But to him, it just seems like he was out there for a couple hours when really, I guess, thousands of years went by on the Earth. So this time dilation is a real thing, not just in science fiction, but it actually takes place with the satellites that go around the Earth right now, the ones that link up with our cell phones for GPS and internet and all that. Um, all of these satellites are experiencing time differently than we are on the Earth. In fact, that very topic is one I have you focus on with the assignment later today. But I just want to show you one more thing, and then I'll let you work on that article. This next slide, I have only a 2-minute video, little cartoon. explaining a little bit about time dilation and what it means. And then this next video I have, or rather, it's a pair of videos. These are videos from Stephen Hawking, or not, not narrated by him the entire time, but they're some of his ideas of how we can take this time dilation reality and do a little bit of time traveling when we eventually have the technology capable of building up enough speed to take advantage of these relativistic effects. So I'd like you to watch both of these videos. They're both only a few minutes long, as well as the 2-minute Einstein time dilation summary. And then after you've had a chance to digest that information, there is also an article about our GPS satellites and how they work and how they are manufactured to take into account this time dilation they experience. So I do hope you enjoy this. Again, I'm mainly focused on just introducing you to these more, rather these less intuitive sides of physics. Hopefully you find this interesting enough and you want to do some research on your own. But as far as the assignments for school goes, I just want you to take a look at these and try the article for now. That's on Google Classroom, of course. Let me know if you have any questions through email, or you can come to a Google Meet, of course. Those are posted on the outline. Enjoy your weekend and take care. We do have a long weekend this week, by the way, if you weren't aware. I don't think we are meeting, we have any official school on Monday for Memorial Day. So enjoy the long weekend, and I'll see you on Tuesday.